I'm Anil Kumar, and in this video we will learn how to solve radical functions. We have taken a few examples with square root. I've written one question here, which is solve square root of x minus 3 equals to 1. Now the strategy here is to isolate square root part. So let me rewrite this question first. We have square root of x minus 3 equals to 1. Isolate means taking 3 on the other side. So we get square root of x equals to 1 plus 3. That is indeed 4. So we have square root of x equals to 4. To find the value of x, we can square both sides. So when you square both sides, you kind of get square root of x square equals to 4 square. So that is x, right? And here it is 16. Now, what you get here is x equals to 16. Now, normally square root of x square is absolute x. Normally square root of x square is actually equals to absolute x. But since we know x is greater than equals to 0, that is the domain. So if x is greater than equals to 0, then this is equals to x. And that is the reason why we wrote x equals to 16. Now, whenever you solve equations involving square root functions, you should check your solution. The reason here is that when you square both sides at this stage, you may incorporate errors, right? So at this stage, you may incorporate errors. Squaring a negative number will give you a positive number also, right? So if I substitute 16 back, I get square root of 16 minus 3. This is my left side equals to, which is 4 minus 3, indeed 1. And since it is equals to right side, we know our solution is correct. And now we can write down our answer as x equals to 16. Now it is kind of necessary to always check your solution. Now let me change this question and then give it to you for solving. We'll just change it slightly. The idea is only to understand the strategy. Instead of plus 3, let me write some other number. Let us say plus 5, right? And let's say 2 here, right? Following the same steps, we can isolate square root x. We get square root x equals to 2 minus 5. So square root x is equals to minus 3. Now if you square both sides, you get what? You get square equals to minus 3 square, right? So that gives you x equals to 9 as your solution. Do you get the idea? Now what I was trying to tell you here is that if I substitute 9 here, the square root of 9 plus 5, that is the left side, is indeed equals to square root of 9 is 3. 3 plus 5, which is 8, which is not 2. Do you see that? So it is incorrect. So this solution is not correct. So this is not correct, right? Not correct solution, right? Therefore, it is important to check. Do you see that? And where is the error? We caused the error at this stage. We squared negative. Now as soon as you get negative on the right side of the square root x, you know square root x is always positive. So we are looking for x which is greater than or equal to 0, and we know the value of square root x will be positive. Therefore at this stage also you could have written no solution, right? So at this stage we could have written no solution. The idea of going back to this question in this fashion is to make it absolutely clear to you that when we square both sides, we do incorporate errors. These are called erroneous roots. We have to check for these roots. And then we can write our answer as no solution. I hope this point is well taken care of. So let's do a few more examples based on square root functions, and then we'll take a few with radical functions with rational exponents. I'm Anil Kumar. You can subscribe and learn a lot from my videos. Thank you and all the best.